In this video, we're going to talk a bit about qualitative analysis. Now, this is going to be the subject of our first lab that we do, and we're not doing labs in the class necessarily this quarter. If this video continues on into perpetuity and it's a later quarter, we will be doing this in a hands-on way. But qualitative analysis is a way to identify what ions are in solution by trying to selectively precipitate or perform another reaction that would identify them. So what we've just learned about precipitation is used a lot when we're talking about qualitative analysis. So in this kind of general lab technique, we create an analytical scheme that's going to utilize selective reactions or precipitations that will allow us to separate an ion and then identify it. And when we develop a scheme or a plan for this, we call it a qualitative analysis scheme. So let's take this example we have here. We've got a mixture of cations, and we're just calling them A, B, and C for now, and they're all dissolved in solution. The qualitative scheme or qualitative analysis scheme strives to choose another reagent to add to this solution that will precipitate out only one of those cations. And so then ideally we would see one of our ions, cation A, form a solid with something that we've added to the solution. Then what we can do once we've formed a solid is we can decant this solution away from the ions that have formed a solid. Now, the solid that forms is called a precipitate, and we've talked about this before. The liquid above the precipitate in one of these schemes is actually has a fun name. It's supernatant. Supernatant liquid. Sometimes, especially if we're doing a crystallization, which this is very similar to, and we then try to separate the crystals from the liquid, we would call that liquid the mother liquor. But that mother liquor would still have a lot of the solution potentially in there. And with solubility products being what they are, we might have a solubility product that is large enough that we still have some of that ion left in solution. So this works best if we're creating precipitates that have very, very, very small solubility products, so that way very little of the cations are still present, or anions are still present in solution. So after we take that supernatant and we pour it off, we'll put it in another test tube. Now we've isolated one of our ions and we have two left. Now a qualitative analysis scheme is going to choose another reagent to add to precipitate out one more of those. So here we've got B, cation B is precipitated out with a new reagent, and we're left with just one ion left in solution in our supernatant liquid. So we decant again into another test tube, and now we've separated out cation B, we've separated out cation A, and we're left with cation C, which means we have effectively separated our mixture. And especially if these precipitates have different colors or kind of physical properties, one's more gel-like, one's more of a fine powder, then it will be able to also say, oh, that first one that came out was probably silver chloride, something like that. It helps us identify them. So here is a summary chart, and I've got kind of a summary of what to expect for qualitative analysis in two different ways here. And this is going to hopefully be a good reference for your lab 1 activity. And this is looking at a lot of cations in this case. We can also do qualitative analysis for anions, which we'll do in our lab. So this one's just looking at cations and some of their properties with how they react with different ions and their solubility. You could extract this same information out of a table of solubility products. This is just a lot easier to digest. It doesn't have the solubility products in here, but you can look those values up. And so what this is showing is that when we add to this giant pile of ions that are all mixed together, if we acidified the solution or added a chloride source from 6 molar hydrochloric acid, which will be protons and chloride ions around, that chloride ion is going to combine with our silver, our lead, and our mercury to form insoluble chlorides with these group 1 elements. Or sorry, with these, the group numbers on this do not correspond to groups in the periodic table. I feel like that is confusing. That first category of insoluble precipitates. So we can form these insoluble chlorides by adding a chloride source. We could also do this with sodium chloride possibly as well. So then we have the remaining pile of cations around. And then if we were to add dihydrogen sulfide with a bit of acid, we would, so under acidic conditions, we would say, we would have our second classification of insoluble solids, and they would be acid insoluble sulfides. And so that gives us copper sulfide and bismuth sulfide, cadmium sulfide, and so on. So we could then separate those ions out that way. Now, if we did a basic addition of hydrogen sulfide, we would get a different category of ions to precipitate out of solution. And so if we take the remaining solution and we add sodium hydroxide until we can increase that pH to something like 8, then we're going to see aluminum hydroxides, iron hydroxides, chromate hydroxides form and fall out of solution. We'll also see some sulfides come out too. So zinc sulfide, nickel sulfide, manganese sulfide, and iron sulfide. And so that'll kind of be our third group or classification, our base insoluble sulfides and hydroxides. So some of these are going to precipitate out because we have a basic environment, and some of them are going to precipitate out with the sulfide under basic conditions. All right, so then we still have a few remaining. There's barium and calcium, magnesium, sodium, potassium, and ammonium. So if we add ammonium hydrogen phosphate and ammonia, we're going to see a fourth classification of our insoluble sulfates form. So this is going to be our barium phosphate. I'm sorry, I said our sulfates, insoluble phosphates. Our calcium phosphate and magnesium ammonium phosphate will be able to precipitate out of solution. And that will get us down to just a handful, just 3 ions left, sodium, potassium, and ammonium, which don't really form precipitates at all. So we could test these by flame test, although the sodium one is such a bright, brilliant goldenrod yellow that it kind of overshadows anything else, and it's really easy to have sodium contamination when you're doing a flame test. The potassium is a much lighter color when you do it. So this is a focus on cation qualitative analysis. And so here's another summary of our cation qualitative analysis. The anions are much more straightforward in general when we're looking at qualitative analysis. And so as you approach your lab activity, I think this is going to be the area that you'll need the most support with. So looking at this, this is a summary of what we saw before in the previous slide as well, that our cations like silver, lead, and mercury are going to form insoluble salts with chloride ions. So we can do that with the addition of hydrochloric acid. We can also do that with the addition of chloride ion. Then we have insoluble compounds that form when there's hydrogen sulfide or sulfide around with acid. And so these require the addition of acid along with the hydrogen sulfide to form. And that's cadmium and copper and bismuth and tin and lead and mercury and arsenic and antimony, SB, antimony. We have our sulfides, and we've got a picture right here of some of the sulfides and what they look like when they actually form a solid. So like we get these bright, brilliant yellow oranges that you can see here. We have then compounds that'll form sulfides under basic conditions as well. And then we have insoluble compounds that'll form precipitates as hydroxides, and that's our chromium, our iron, and our aluminum. And these form, especially the aluminum one, kind of a more gel-like precipitate rather than something that's more of a fine powder. And then we have our phosphates here, and then our flame test right there. So again, please use this as a resource as you work through your lab activity.